Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haytham Aly, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today, we will have some questions, multiple choice question, to recall the basic engine thrust reverser system operation. Basic engine thrust reverser system operation. This quiz is for my fellow pilots and aircraft maintenance personnel. Okay, so let's join the quiz right now. Haytham Aly. And let's start the quiz right now. Basic engine thrust reverser system quiz. Okay. So, question 1 of 25. The reverse thrust lever activates the thrust reverser. Just a moment. The reverse thrust lever activates the thrust reverser and provide a variable fuel flow to the engine. This statement is very true. Okay. So, yes, the reverse thrust lever or thrust reverser latching lever allows the throttle lever to go to the reverse thrust part, like idle reverse and the maximum reverse. So first you need to put the throttle lever or thrust lever on the idle reverse and allow the translating sleeve or blocker door to fully open. Then you can take the throttle lever or thrust reverse lever into a maximum reverse. In that case, fuel flow increase to the combustion chamber and the thrust from the engine increase, so that reverse thrust will increase to stop the aircraft within a limited distance. So yes, the reverse thrust lever activates the thrust reverser and provide a variable fuel flow to the engine when you take the throttle lever from idle reverse to maximum reverse. Okay, everybody. Let's proceed for the next question. Question 2 of 25. We cannot control the engine thrust during reverser operation. No, this statement is false. Yes, we can control engine thrust when the throttle lever or thrust lever at the idle section. at the reverse section. Because we take the thrust lever first at reverse idle, then we can take it to a maximum reverse. Now the thrust will increase and the thrust reverse will increase. Allow a high brake efficiency by the engine. Okay, so let's proceed for the next question, everybody. Question 3 of 25. Reverse thrust cannot normally be applied until the forward thrust lever is in the idle position. Reverse thrust cannot normally be applied until the forward thrust lever is in the idle position. This statement is true. In order to have reverse thrust, first the normal thrust lever must be at the idle detent. And all the engine of the aircraft must be at the idle detent or idle power. And it's always coming as a check between each engine. So normally you cannot take one engine to reverse thrust until you assure from the other engines that they are on idle. Okay, so as you can see here, we can take the reverse thrust levers into the reverse thrust, but first the normal lever must be at the idle detent or idle position. So yes, this statement is true. Reverse thrust cannot normally be applied until the forward thrust lever is in the idle position. Okay, everybody, let's proceed for the next question. The action of lifting up the reverse thrust lever also locks the forward thrust lever at idle. Yes, this statement is true. This statement is true. The action of lifting up the reverse thrust lever also locks the forward thrust lever at idle. When you assure that the forward thrust lever at idle and you lift up the reverse thrust lever, now the forward thrust lever will be locked at the idle position to assure that all engines at idle before taking any engine to the reverse thrust section. Before taking any engine to the reverse thrust section. So as you can see here, once the forward thrust lever is in the idle position, the reverse thrust lever is unlocked. And by lifting up this lever, an increase in engine reverse thrust can be applied. Yes, you can take the engines first to a reverse idle and allows the thrust reverser blocker doors or translating sleeve to be fully deployed first. Then you can take it to a maximum reverse and increase the engine thrust. So it must be noted, however, that the action of lifting up the reverse thrust lever also locks the forward thrust lever at idle, therefore preventing the movement of this lever to the forward thrust mode. Okay, so always there is a rule that you cannot take one engine to the reverse thrust until you check or until this engine checks that the other engine are at or near idle position. Idle position. Okay, everybody, let's proceed for the next question. Question 5 of 25. For thrust reverser controls, we have flight deck control lever, engine control box, all the mentioned above. So the right answer is all the mentioned above. So for thrust reverser control, yes, in the cockpit we always have flight deck control lever. Like on some aircraft, we have forward thrust lever and reverse thrust levers. And some other aircraft, we have throttle levers beside a thrust reverser latching mechanism. Also, the engine control box, there must be a connection between the flight deck control lever and the engine control box. If the engine is mechanically controlled, so there is an engine control box. Or if the engine is FADEC control, there will be an electric signal from the throttle lever and the thrust reverser latching levers with the electronic control unit of the engine. So yes, for thrust reverser controls, we have flight deck control lever and an engine control box. Okay, everybody, let's proceed for the next question. I hope you enjoy my aviation nuggets. Please stay tuned always for an upcoming session like this, and don't forget to subscribe to my YouTube channel. Thank you so much. Let's proceed for the next question. The strut box incorporates the various cable for the engine fuel control, forward reverse thrust cable, and the feedback cables. Yes. So the right answer is all the mentioned above. Engine control box or engine strut box in a mechanically controlled engine, always connected to the cockpit control levers for forward thrust or reverse thrust. And there is always a mean by this strut box to control engine fuel supply, forward and reverse thrust cable connected from the control lever in the cockpit into the strut box on the engine, and feedback cables coming from the strut box to the cockpit. So the right answer is all the mentioned above. Okay, everybody, let's proceed for the next question. A major control item for thrust reversal operation which is away from the flight deck is. A major control item for thrust reversal operation which is away from the flight deck is the forward thrust lever, engine control box, reverse thrust lever. the engine control box or the computer for a FADC engine is a major computer or a major control item for thrust reverser operation. And always in the FADC control engine, the electronic control unit of the engine or the electronic engine control of the engine is the main computer and the first line of defense to allow operation of thrust reverser only on ground. Probably most of the engine we will have like 3 control computer. Like for the Airbus A320, we have electronic engine control, engine interface unit, and a third computer, like a third line of defense, which must be an independent computer or an aircraft system computer. And Airbus choose the spoiler elevator computer. Spoiler elevator computer. Yes, so the engine control box is a major control item for thrust reverser operation, which is away from the flight deck. In the flight deck, for control of the thrust reverse, we always have forward thrust lever and a reverse thrust lever to allow the pilot to manually select the thrust reverse on ground after landing. Okay, everybody, let's proceed for the next question. Question 8 of 25. An increase in engine power in the reverse mode cannot take place until the doors or translating sleeves have fully opened. Again, an increase in engine power in the reverse mode cannot take place until the doors or translating sleeve have fully opened. Yes, this statement is very true. Because normally you can take the engine to a reverse idle and allow the pivoting door or translating sleeve to be fully opened first. When you satisfy with that, you can increase power and take it from a reverse idle to a maximum reverse. Reverse idle to a maximum reverse. Okay, everybody, let's proceed for the next question. I hope you enjoy this set of questions prepared by Haytham Aly. Prepared by Haytham Aly. Okay, everybody. Other components within the reverser system are the isolation valve, directional control valve, all the mentioned above. The right answer is all the mentioned above. Always we have a component located probably in the pylon, which is called hydraulic control unit, which controls the hydraulic supply to the actuator of the thrust reverser system. Always this hydraulic control unit allow hydraulic only to the actuator of thrust reverser only when aircraft is on ground. Only when aircraft is on ground. And always this hydraulic control unit do have an isolation valve and a directional control valve. This isolation valve and the directional control valve, always they are solenoid valve and they will be energized by the engine computer. Okay, so what is the function of the isolation valve? The isolation valve is allow hydraulic to the actuator of thrust reverser or not. If it is energized, it will allow hydraulic. If it is not energized, it will stop hydraulic for the actuator. Other valve on the hydraulic control unit is a directional control valve, which control the hydraulic to which side of the actuator. You need to stow the reverse or you need to deploy the reverse. So this is a function of the directional control valve. And always the isolation valve do have a manual lever to allow maintenance personnel to deactivate the hydraulic supply to the thrust reverser when they are operating the thrust reverser when they are working in the area of the thrust reverse to prevent inadvertent operation of the thrust reverser system. And also if they need to deactivate the thrust reverser for flight, they do the hydraulic deactivation from the hydraulic control unit by having this manual lever and close the isolation valve. Remember always everybody that if you need to deactivate the thrust reverser for an aircraft dispatch for flight, you need to do a hydraulic deactivation from the hydraulic control unit and you need to do a mechanical deactivation by inserting the lock pins on the thrust reverser translating sleeve to lock the thrust reverser cowl with the engine case and allow the pivoting blocker doors or translating sleeve to be locked, mechanically locked with the engine case. Okay, everybody, let's proceed for the next question. In normal circumstances, control of the reverser doors is achieved by, in normal circumstances, control of the reverser doors is achieved by pneumatic power, hydraulic power, A or B? Yes, the right answer is A or B. In most of the aircraft, hydraulic power actuate the thrust reverser door. In most of the aircraft, hydraulic power are being used to allow the pivoting door or translating sleeve to move rearward. Okay, everybody, we can see this video for thrust reverser operation. As you can see here, now the thrust reverser will operate. Translating sleeve are going rearward. Allow the cascade vane to direct the fan stream into a forward position. So here in this aircraft, the translating sleeve are going rearward by hydraulic power. In some other aircraft engine, pneumatic power may be used to allow the actuator to move the translating sleeve. Now the translating sleeve going forward allows the pivoting blocker doors to prevent rearward thrust and do a forward thrust, and the cascade vane allows the forward air or the fan air to go into a forward direction away from the critical component of the aircraft. Okay, everybody, let's proceed for the next question. Question 11 of 25. The isolation valve is used to isolate the reverser system from the aircraft hydraulic pneumatic system. Yes, this statement is true. And always remember that the isolation valve is an on-off valve located in a hydraulic control unit. If it is energized by the engine computer, it allows hydraulic to go to the thrust reverser actuator. And if it is not energized or de-energized, it will close and prevent hydraulic supply going to the actuator of the thrust reverser system. So remember always that the hydraulic control unit do have an isolation valve and a directional control valve. Okay, everybody, let's proceed for the next question. The operation of the isolation valve is controlled by a solenoid that is electrically energized. This statement is true. Again, the operation of the isolation valve is controlled by a solenoid that is electrically energized. The electronic engine controller will energize the isolation valve only when the aircraft is on ground. So there must be a condition that the aircraft is on ground. For example, the landing gear computer must tell the engine computer that the aircraft is on ground. Or the spoiler elevator computer or the spoiler computer must tell the engine computer that the ground spoiler is deployed now, so that we are on ground and the landing gear is compressed. So the engine computer now can energize the solenoid of the isolation valve and allow hydraulic to reach the actuator and deploy the thrust reverse. Again, the isolation valve is an on-off valve which allows the hydraulic supply going to the thrust reverser actuators or not. So it is an on-off valve. Okay, everybody, let's proceed for the next question. Question 13 of 25. A means of mechanically isolating the system from operation incorporated into. A means of mechanically isolating the system, thrust reverser system, from operation incorporated into the isolation valve or the directional control valve. As I told you, the isolation valve always have a lever, and the maintenance people can close the isolation valve mechanically from accessing the hydraulic control unit to prevent and to assure that hydraulic supply will not going to the thrust reverser actuator, because they may be working in the area of the engine and they don't need an inadvertent operation of the thrust reverse for the safety of people and the engine. And also if they need to deactivate thrust reverser for flight, so they will do hydraulic deactivation from the hydraulic control unit. So they will close the hydraulic supply by the lever on the hydraulic control unit that will close manually the isolation valve. The isolation valve. Okay, everybody, let's proceed for the next question. To disable the system and prevent it from operating inadvertently during the maintenance of the reverser system, deactivate the isolation valve, install the lockout pins, all the mentioned above. So again the question, to disable the system and prevent it from operating inadvertently during the maintenance of the reverse system. Mainly we deactivate the isolation valve. So for thrust reverser deactivation for maintenance, only we do hydraulic deactivation by closing the isolation valve from the lever on the hydraulic control unit. But if we need to do thrust reverser deactivation for flight, we add a mechanical locking of the thrust reverser system. Mechanical deactivation. We do the hydraulic deactivation and also we can do the mechanical deactivation. But if we are on ground, as you can see here from this video, we can only deactivate the isolation valve. So as you can see here, this is a video of an aircraft landing and the thrust reverser is operating now. Condition must be satisfied. Aircraft on ground, landing gear compressed, spoiler are extended, ground spoiler. So now thrust reverser can be operated. So it is a translating sleeve for the V2500 engine. So we can see now how the maintenance people, will deactivate the thrust reverser system for maintenance by closing the isolation valve, or hydraulic deactivate the thrust reverser. Some action must be done from the cockpit and the other action must be done on the hydraulic control unit.
Engine FADEC ground power switch is off and install a warning notice.
Engine FADEC ground power off. Engine FADEC ground power must be off because we will work in the area of the engine. Now the mechanic will open the fan cowl and access to the hydraulic control unit, and will do an access to the hydraulic control unit, accessing the lever on the hydraulic control unit, and will shut down or deactivate the isolation valve. You see, releasing the pin and closing the isolation valve. This is a maintenance deactivation for the thrust reverse. If the aircraft will fly, we cannot only do the hydraulic deactivation, but we always need to do the mechanical deactivation. Insert a pin to satisfy that the translating sleeve will be locked with the engine case, and also a mechanical deactivation happening. So what you are seeing now is a mechanical deactivation. Okay, everybody, let's proceed for the next question. Question 15 of 25. To disable the thrust reverser system and prevent it from operating inadvertently during flight. We deactivate the isolation valve mechanically, or install the lockout pins, or all the mentioned above. As I told you, if you need to disable the thrust reverser system and prevent it from operating inadvertently during flight, so it is called thrust reverser deactivation for flight, we need to do hydraulic deactivation and also mechanical deactivation. Both of them must be happen. So the right answer is all the mentioned above. All the mentioned above. Okay, everybody, let's proceed for the next question. Next one. Board's pressure to the control actuator during selection of reverse thrust. Board's pressure to the control actuator during selection of reverse thrust. It is the isolation valve, or directional control valve, or electronic control box. As I told you, probably the directional control valve will allow to stow or to deploy the thrust reverser. To stow or to deploy the thrust reverser. So the directional control valve always has the function to allow the hydraulic to go to the stow side of the actuator or deploy side of the actuator. Deploy side of the actuator. Okay, everybody, let's proceed for the next question. It boards pressure to either the deploy or the stow side of the actuator, depending upon the selection made. Is it the isolation valve or directional control valve or all the mentioned above? The right answer is directional control valve. Directional control valve. As I mentioned, in the hydraulic control unit, a directional control valve boards pressure to either the deploy side of the actuator or stow side of the actuator, depending upon the selection made from the cockpit. The isolation valve only has the function to allow the hydraulic to go to the actuator or not. So the directional control valve can only operate when the isolation valve is open. Okay, everybody, let's proceed for the next question. I hope you enjoy these sets of questions. True or false, the isolation valve, when energized by the reverse thrust lever, allows pressure to go to the directional control valve. Again, the isolation valve, when energized by the reverse thrust lever, allow pressure to go to the directional control valve. This statement is very true. This statement is very true. Yes, the isolation valve must be open first. So now the hydraulic can go to the directional control valve. And now the directional control valve has the function to allow the hydraulic to port into the stow side of the actuator or the deploy side of the actuator. Stow side or deploy side of the actuator. Okay, everybody, next one. During fan stream reverser operation, the blocker doors close off the fan stream. How is this achieved? Again, during fan stream reverser operation, the blocker door close off the fan stream. How is this achieved? By the rearward movement of the translating sleeve, blocker doors moved electrically. The right answer is by the rearward movement of the translating sleeve. Only when the translating sleeve going to the rearward, it allows the drag link to operate the blocker door, and now the blocker door will block the fan stream and allow a forward thrust to be reverted to a reverse thrust. So only the blocker door will close and prevent the fan stream from going rearward and allow it to go to forward by the rearward movement of the translating sleeve. Main component of the thrust reverser system is the thrust reverser actuator, translating sleeve, blocker doors, and the hydraulic control unit. Okay, everybody, let's proceed for the next question. Last 5 questions. Feedback cables installed in thrust reverser system control. Feedback cables installed in thrust reverser system control. Yes, this statement is very true. This statement is very true. Always there must be a feedback from the engine to the cockpit that the thrust reverser system is deployed now. Fully deploy, doors open, or translating sleeve rearward, or translating sleeve close. Blocker doors are fully deployed, or blocker doors are now stowed. There must be an indication and a feedback coming from the engine to the cockpit to satisfy the pilot about the operation of the thrust reverser system. Okay, everybody, let's proceed for the next one. Before reverse thrust can be selected, the forward thrust lever must be at idle. Yes. Before reverse thrust can be selected, the forward thrust lever must be at idle position. Only when the forward thrust lever at idle, you can take the throttle lever into a reverse thrust segment. Next one. The purpose of cascade vanes is that they direct gas flow rearward onto the fan blades in a forward direction. Again, the purpose of a cascade vane is that they direct gas flow in a forward direction. The right answer is in a forward direction. And the function of the cascade vane is to direct the fan stream forward, but yet away from the critical component of the aircraft. And my maintenance people, always take care, if you remove the cascade vane segment, you need to reinstall it on the corrected position, because each cascade vane segment do have certain angles and do direct the fan stream forward. In a certain angles. Okay, everybody, let's proceed for the next question. Question 23 of 25. The electric solenoid on the isolation valve receives its signal from the reverse thrust lever, directional control valve, strut, drum box. The electric solenoid on the isolation valve receives its signal from the reverse thrust lever, or on a FADEC engine from the electronic control box or the engine controller. In a modern airliner, the engine controller has the responsibility to energize the solenoid of the isolation valve and also the directional valve on the hydraulic control unit. Okay, everybody, let's proceed for the next question. The directional control valve is activated by a mechanical signal from the strut box, isolation valve, feedback cable. The directional control valve is achieved by a mechanical signal from the strut box, isolation valve, feedback cable. I think it is from the strut box. Okay, everybody, let's proceed for the next question. Question 25 of 25. As a safety, pins can be inserted into the system to prevent inadvertent operation during maintenance. They inserted in the feedback cable, strut box, isolation valve. Again, as a safety, pins can be inserted into the system to prevent inadvertent operation during maintenance. They inserted in the feedback cable, strut box, isolation valve. The right answer is isolation valve. 4. Thrust reverser deactivation for maintenance. You always close the isolation valve by the deactivation lever, and you need to insert the pins to allow the hydraulic prevented from going to the hydraulic actuator of the thrust reverser system. Thank you for your good listening. Thank you, everybody, my fellow pilots and aircraft maintenance personnel, for your good listening. And always fly safely and maintain your aircraft very safely. Your host was Haytham Aly. Please stay tuned for upcoming sessions like this to recall aircraft system from a set of multiple choice questions prepared by Aviation Nuggets by Haytham Aly. Thank you. Have a good day and I will meet you very soon. Bye bye.